Question 3. In the diagram A with coordinates -9 and 12, B with coordinates 9 and 9, C -3 to -9 are the vertices of the triangle ABC. Let's look at the triangle ABC here, A, B, and C. Now, they say N, which is this point right here, is a point such that BN is equal to 5√5. So the distance from B to N is going to be 5√5. R is the point on AB, and S is a point on AB, and S is a point on BC. Let's see S, here's S, and here's R. They are points on AB and BC respectively, R and S. Such that RNS is parallel to AC. Now, RNS is going to be parallel to AC. Any two parallel lines have equal gradients. In other words, the gradient of AC is equal to the gradient of RNS. Okay. And RNS passes through the origin, and it happens to pass through the origin. We know the coordinates of the origin, 0 to 0. T lies on the x-axis to the right of P. So here's T on the x-axis to the right of P, and then they say we must name ACB, the angle ACB as theta, AMO, I think this is the one. They say we must name it as alpha, yes, alpha, and then PBT, BPT as beta. Now, you will realize that this BPT is also equal to this OPS, which is also going to be beta. But if we do need to make that note, you will see as time goes on. Let's answer these questions. The first question is asking us to calculate the gradient of the line AC. Now, the formula for the gradient is straightforward. The gradient of any line, in this case AC, is equal to y2 minus y1 over x2 minus x1. Okay? And we have to choose a point 1 and point 2, and then substitute accordingly. It doesn't matter which one is your 1 and which one is your 2. We can call A our x1, y1, and then we can call C our x2, y2. So if C has our y2, we will say -9 minus A that has our y1, which is 12, over x2 is going to be -3 minus -9. So minus -9. Make sure all the negatives that appear are also present. So we've got -9 minus 12 divided by -3 minus -9. And the answer is going to be -7/2. That is the gradient of AC. Let's just write it down here, -7/2. or 3.1. They want the equation of the line RNS. The equation of RNS. And remember what they told us. They told us that RNS is parallel to AC. So the gradient of RNS is equal to the gradient of AC, which is -7/2. Now, an equation of a straight line is given by this, y equals mx plus c, so the equation of RNS is y is equal to -7/2x plus c. Our job is to find c. It is very easy to find c. All it takes is substituting a point that that particular line passes through. RNS passes through R, it passes through N, it passes through the origin, and it passes through S. Which of these points has full coordinates? Clearly it's the origin. The origin has the complete coordinates. So to find C, we just have to substitute the coordinates of point O. So we can say using O, which is 0 is to 0. Where there is y, we will substitute a 0. And where there is x, we will also substitute a 0. Plus c. We will soon realize that c is equal to 0, and the equation of the line is y is equal to -7/2x, and that is it. They want us to calculate the value of a. This one here. A is the x coordinate of n. N belongs on the line RNC. Belongs on the line RNS, sorry, not RNC, RNS. Now to find the coordinate, the x coordinate of n, we must substitute the y coordinate of n on this equation here. So I'm going to write 3.3 this side. So we will have the y coordinate of n is 7. So we've got 7 is equal to -7/2 times x, but they told us that the x is a. We are trying to solve for x. So what we could do, or for a, what we could do, we could multiply both sides by 2. We've got 14 this side and -7a this side, because the 2's will cancel, and we can divide by -7. So a is equal to -2. Another thing we could have done, we could have just divided by -7/2 both sides, and we would have gotten the answer. So our a is -2 and our y is 7. And from where the point is, it makes sense. So that is the value of a. And then lastly, they want us to calculate the size of theta. Let's look at where theta is. There is no formula to find theta as it belongs to this point. However, there are formulas to find beta and alpha. Remember, beta is an angle of inclination for a positive gradient. Clearly, when the straight line is increasing as x increases, it has a positive gradient. So it is easy here. We will just say to find beta is going to be arctan of the gradient BC, and that is it. Now to find alpha, because alpha is the angle of inclination, or we could say even the angle of declination of the straight line with a negative gradient, we can say alpha is equal to arctan of gradient AC plus 180 degrees. okay? And in some way, we will manipulate these two values in order to find theta. I will show you how. For now, let's find beta and alpha. So in order for us to find beta, we have to first find the gradient of BC. But let's start with alpha. So 3.4. We just said alpha is going to be the grade is going to be equal to arctan of the gradient of AC, and then we add 180 to that. What is the gradient of AC? This is arctan of, what was the value? It was -7/2. We will substitute it as it is. -7/2 plus 180 degrees. So this right here is going to be arctan, so shift and tan of -7/2 plus 180, and my calculator says this is 105.95. Now to find beta, we have to first calculate the gradient of BC. Now the gradient of BC, just like we calculated the gradient of AC, we just say change in y over change in x. So I'm going to say 9 minus -9 over 9 minus -3. So this is going to be 9 minus -9 over 9 minus -3. And this is 18/12. 6 goes 3 times into 18 and twice, so this is going to be a 3/2 positive gradient as we expected. Now to find beta, we said it's just going to simply be arctan of the 3/2, which in our case should give us 56.31. Now let's look at geometry, the geometry of this shape. I did say earlier that this angle beta is also existent this side. I just want us to use this triangle here, MPC. If you're looking at this angle MPC, then you will see something special. Beta and theta are interior angles, while alpha is an exterior angle. What does this mean? It means alpha is going to be equal to beta plus theta. That is the exterior angle of any triangle. In any triangle, if we have an exterior angle, let me call it alpha, and then the other ones are theta and beta, this exterior angle is equal to the sum of these ones, not this one here. Okay, so that is what we will do. We will say alpha is equal to beta plus theta. This means that theta is just going to be alpha minus beta, and that is what we are trying to calculate. So this means theta is alpha minus beta, and it makes sense. Alpha is a bigger number, it's 105.95, minus beta, which is 56.31, and then you get your answer. So it's 105 point minus 56 point, and that is your 49.64. quite nicely done. That was the answers to to question 3. We can now move on to the next question, question 4. So in question 4 they say A with coordinates -8 and 6, B, C, and D with coordinates 3 and 9 are the vertices of a rhombus. Let's remind ourselves what a rhombus is. A rhombus is a skewed square. Right? It looks like a square. It has some properties like a square. All sides are equal. Opposite sides are parallel. So side, 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 side. Unlike a square, these are obtuse angles while these ones are acute angles. For a square, they are all 90 degrees. However, for a rhombus, the diagonals intersect at 90 degrees and at a midpoint. So this intersection is a midpoint of each diagonal, let's say AC and BD. They share the same midpoint, AC and BD, but they also intersect. These lines AC and BD intersect at a 90 degrees. That is what a rhombus is. Just keep in mind. Now they say the equation of BD is 3x minus y equals 0. We are usually given equations as y is equal to mx plus c. It's going to be our task to change this equation so that it looks like mx plus c. The diagonals of the rhombus intersect at point K. So now we know that point K is the midpoint of DB and it's also the midpoint of AC. And according to properties of a rhombus, this is a 90 degrees. They are perpendicular to each other. Right? Now, first question is asking us to calculate the perimeter of A, B, C, D. Remember, perimeter is just the sum of all sides. So it would be side plus side plus side plus side. In other words, it's 4 times side. So we just need to find one side of the rhombus and then we use that as our perimeter. And clearly, the only side we are able to find is AD. So let's find AD. This is 4.1. AD, if you remember the formula very well, the formula says it's the square root x2 minus x1 squared plus y2 minus y1 squared. We do the same thing. Decide any point between A and D to be your x1, y1, and the other one as your x2, y2. So let's say 2 is point D and 1 is point A. So this is going to be 3 minus negative 8 squared plus 9 minus 6. So anyway, let's just punch it into our calculator. 3 minus negative 8 is 11 squared, which is 121. So plus 9 minus 6 is 3 squared, which is 9. And our answer is just the square root of 130. Let's leave it in third form. Now, each one of these sides here is just the square root of 130 units. So when it comes to the perimeter, it's just going to be 4 times 1 plus times the root of 130. And then that is it. Now they want us to determine the equation of diagonal AC. Now AC is this line here. They want the equation of it. To find the equation, we must find its gradient and the y-intercept. Now, all we know is that AC is perpendicular to BD. It's very difficult to find the gradient of AC from its coordinates because we are only given one coordinate. AC passes through A, K, and C. But K and C has no coordinates. So we must use the perpendicular lines. Remember, they said BD has an equation 3x minus y equals 0. So let's start there. Let's start with the equation of BD, 4.2. BD, we know it's 3x minus y is equal to 0. If you send the y to this side, you have 3x equals y, or y is equal to 3x. So the gradient of BD, this means the gradient of BD is equal to 3. Since BD and AC are perpendicular to each other, and we have to say that BD is perpendicular to AC. The reason why is because these are diagonals of a rhombus. Since they are perpendicular, it means the gradient of BD multiplied by the gradient of AC is equal to -1. So this is 3 times gradient of AC, which is -1. If you divide by 3, you will find that the gradient of AC is just -1 over 3. Now we know that the equation of AC is now y is equal to -1 over 3x plus c. Like I said in the previous question, whenever you're looking for c, use one point that line passes through. So which line are we looking at? We are looking at AC. AC passes through A, it passes through K, and it passes through C. Now which point can we use? We can use A because it has both coordinates, -8 and 6 for x and y respectively. So we will say A with coordinates -8 and 6, right? We substitute these points. Where there is y, we put a 6, -1 over 3. Where there is x, we put a -8. So this is plus c. This will give us an 8 over 3. And 8 over 3 plus c. While this one is still a 6. If you take the 8 over 3 and bring it this side, 6 is the same thing as 18 over 3. So this should be 10 over 3 is equal to c. So the equation then becomes y is equal to -1 over 3x plus 10 over 3. And that is your equation for AC. Now the next question, they say calculate the coordinates of K if the equation of AC is x plus 3y is equal to 10. So here they are giving us the equation of AC. Let's just verify that this equation of AC is the same as ours. They say it's x plus 3y equals 10. We want to make y the subject of the formula, so we need to send x to the other side. So this is 3y is equal to negative x plus 10. And then you can divide by 3, divide by 3, divide by 3. You get y is equal to negative 1 over 3x plus 10 over 3, which is exactly what we have. So if what we have is the original equation for AC, we must find the coordinates of K. Now to find the coordinates of K is the point of intersection of AC and BD. At a point of intersection, we equate the graphs, right? So I'm going to write this right here, 4.3. So K is point of intersection of AC and BD. So what does that tell us? It tells us that we can take AC, the equation of AC, and say negative 1 over 3x plus 10 over 3 is equal to the equation of BD. The equation of BD was 3x, like this. And then we try to solve, we collect like terms. Take the 1 over 3 to this side, so 10 over 3 will stay here. 1 over 3x plus 3 is the same thing as 9 over 3, so this is actually going to be 10 over 3x. If we divide, we will find that x is 1 if you divide both sides by 10 over 3. If x is 1, then y is going to be, use any one of these equations, either this one or the other one or this one. I'm going to use the easiest looking one, so that's going to be 3 times 1, which is also 3. So the coordinates of K are 1 and 3. Another way we could have done was we could have tried looking for the midpoint of K, maybe by finding first the coordinates of C. Once you have the coordinates of C, because C is the x-intercept, y is equal to 0, we can easily find the coordinates of C, right? Once we have found the coordinates of C, our job is then to find the midpoint of AC, which is K. It should give us pretty much the same answers. Now, the next question is that we calculate the coordinates of B. Remember, B is this point here. We just found that K is 1:3. Like this. So B rather, is a point like this one. But K is the midpoint of B and D. So we can go on to also say this is supposed to be 4.4. We can also say K is midpoint of B, D. What do we know about midpoints? We know that x of a midpoint, like for instance x of K, is equal to x of B plus x of D over 2. And then y of the midpoint, in this case our midpoint is K, is equal to y of B plus y of D over 2. Remember, this on this side, on the left hand side, belongs to the midpoint, and these ones belong to the side points. So the midpoint is K, but the side points are B and D. You can call them x1, x2, it's all right. So we know that the x of k is 1. We are looking for the x of b. Now what is the x of d? X of d is 3 over 2. If you try to solve, we can cross multiply. 2 times 1 is 2, and then this is x of b plus 3, so that x of b is equal to -1 if you send the 3 to the other side. Just solve it to be sure. And then the y of k is 3. We are looking for the y of b. What is the y of d? It's 9. So we just have to substitute a 9 here, divide by 2. If we cross multiply again, 2 times 3 is 6, and this is y of b plus 9. If you send the 9 to the other side, you will find that the y of b is -3. So b's coordinates are -1 and -3. Let's see if they belong to the right place. Yes, b is in the third quadrant where x is negative, so we can imagine this as being -1 and this being -3 because it's not drawn to scale. So that was our 4.4. Now 4.5, they say show all your calculations. Determine showing all your calculations whether the rhombus ABCD is a square or not. Now, I did say something that the difference between a rhombus and a square, everything else is the same except that a square looks a little bit like this, and even if the sides are all equal and the pairs of opposite sides are parallel, but the square intersect at a 90 degrees. So, or rather the sides, the adjacent sides intersect at a 90 degrees, while a rhombus will either be an acute or an obtuse angle. So our job is just to show that. We just have to show one angle that it's not equal to 90. If one angle is not equal to 90, then basically all of the angles are not equal to 90. Now, we already know that this side is 130 units. Maybe let's say this one is also, it's the square root of 130 units. We now know that this side and this side are both 130. We might as well try to find this red side here, BD. If we find BD, and then after finding BD, we try to look for this angle here using the cosine rule. Remember, the cosine rule says that BD squared is equal to AD squared plus AB squared minus 2AD AB cosine of A. That is what we are going to try and do and try to solve for A, right? So let's just find BD first. So this is 4.5. To find BD, it's just going to be the square root. We've written the formula before, x2 minus x1. So here's B, it's -3. Sorry, it's -1. And then D, I think we did say D, the coordinate for D is 3. So it's 3. So -1 minus 3 squared plus B again is -1. -3, the x value, the y value, -3 minus D, which is 9 squared. Let's find this length. In third form, it's 4 root 10 units. It's 4 root 10 units. Now, I'm going to just draw a triangle randomly and give it these names. We've got A, D, and B. Let's say this is our A, this is our, this one is our D, and then this one is our B. We found that AB is the square root of 130, and we also found that AD is also the square root of 130. And then BD, we just saw that it's 4 root 10. Now, the cosine rule says that BD squared is equal to AB squared plus AD squared minus 2 times AB times AD, and then cosine of the angle that is opposite BD, which is A. Right? If we can find that A is not 90 degrees, then this is not a square. But if we find that A is 90 degrees, then this is definitely a square. Right? So that is what we are trying to look for. So this is going to be 4 root 10 squared. And then this is going to be the root of 130 squared plus another root of 130 squared minus 2 the root of 130. Let me just try to shift this. Root of 130 again, cosine of A. So this is 16 times 10, which is 160. This is 130 plus 130 minus 2 times 130, which is 260. Right? Cos A. If you bring this 130 this side, 160 minus 130, that's going to be 30, and then you bring another 130 this side, that's going to be a negative 100, is equal to negative 260 cos A. If we divide by negative 260, negative 260, these will cancel. This is going to be 5 over 13. So cos A is equal to 5 over 13. Now, A is going to be a cos of 5 over 13. And what is our answer? Remember, A is an angle, so don't forget the angle cap. So the answer is 67.38. That is the answer we are getting. It is about 67.38, which is not 90 degrees. So since it's not 90 degrees, it means it's not a square. And then that is it for these questions.